Welcome to another of Mr. Adler's flipped lessons. Today we want to talk about graphs because graphs are an important way to present data, but they're also useful for more than just that. You're going to be gathering data in your class and you want to present that and you want to be able to do more. So you might get data something like this. Now, this is not really the typical kind of science lab data that we're going to get, but if you're looking at it, hopefully you can see where I'm going with this. Stay in school, kids. It's good for you. What we have is a set of data that shows the number of years of education a person completes and their median weekly pay, about how much they're going to get. We want to take that data and we want to present it in a graph form. Now, when you make a graph, the purpose of this lesson today is to show you that there are certain rules for making a graph. Rules that are, I guess, universal. For all graphs, they need to have certain things. But then also for me, I have specific demands that I'd like you to follow. They're not too tough, but you can't forget about them. I want you to turn in a lab correctly the first time so that you don't have to fix it later. So that's what this lesson's about. Then we're going to talk about what else we can do with this data. One of the universal rules that I should follow more, and so I'm putting it on this recording so that you remember, is graphs should have a title. We're going to label the x and the y axis also. We're going to talk about that because sometimes that's confusing. But don't forget to put a title. This is a graph that's supposed to show how many years of education you have compared to the amount of pay you might get. So that should be the title. Years of education versus pay. Now, we've got two columns worth of data. The number of years you're in school and the amount of money you might make per week. Which goes on the x-axis, which goes on the y-axis. Sometimes that's confusing for people. And here's where math and science work together. You've probably done a lot of graphing in math as well as science, and hopefully you've heard these terms. If not, this is part of the lesson. Both the x and the y-axis have special names. One of them's called the independent variable, one of them is the dependent variable. And what you can think about in terms of your data is what's the cause and what's the effect of from the data you gathered. Okay? The independent variable always goes on the x-axis. And while I'm writing this, I might point out that you could be taking notes while you're watching this as well. The dependent variable goes on the y-axis. Now, what's the difference? The independent variable is the cause. The dependent variable is the effect. So look at this data. What's the cause? What's the effect? Do the years of education cause you to have a different pay, your effect? Or does the amount of pay you have cause how many years you're in school? Hopefully you've thought about it for a couple seconds here, or you've hit pause and thought about it even longer, and you've thought that the number of years determines your pay. So the number of years is the cause, the independent variable. The effect, the dependent variable, is your pay. So that's what you would label on your x and your y axis. Okay? Years of education and pay. I'm going to make this a little quicker. Okay? Now I'm going to get some of this stuff out of the way. Hopefully you have that in your notes, or you're going to go back and put it in your notes. So that's some big time stuff for all graphs. Making a title. Don't forget to do that. Putting the independent and the dependent variable on the right axes. Otherwise it's confusing. So those are some universal rules. Now there's a couple rules that I want you to follow. First rule, both the x and the y axis will start at 0. The data we have, the years start at 10, the pay starts at 450, that doesn't matter. I want you to always start the x and the y-axis at 0. You're going to space out your data evenly. It could be different spacing. The years only go up to 20. we only have to fit 0 to 20 on the x-axis. That's not too bad. We don't have to label 1, 2, 3, 4, 5. Since it's 20, we can make our lives a little bit easier. Maybe go by quarters. 5, 10, 15, 20. It's going to be pretty easy for you because you're going to be using graph paper. Always use graph paper. Don't go home, do a graph on notebook paper and come in and say, hey, is this okay? Because the answer is going to be no, and you'll be upset at that. So make sure you have graph paper. I've got plenty for you in class. Take advantage of that. So that's a nice x-axis. Our y-axis has to go up to at least $1,550. That's the highest number we have. You don't have to make it go exactly to $1,550. In my head, I'm thinking if we go up to $1,600, I can break it up nice and easy on my y-axis. Okay? If I make the top 1,600, okay, or you might need to count squares on your graph paper to make it go to nearly the top of your piece of graph paper. You're going to use the whole piece of graph paper I gave you. It's free. You might break it down into quarters again, or whatever works to make it spread out evenly. Okay? I'm doing this on a smartboard, so you don't see graph paper on here. But you would have to make each square on the x-axis maybe be worth 1 year. Each square on the y-axis maybe be worth $50, something like that. And you continue to use that spacing for the axes. Now you have to plot your points. And hopefully you're pretty good at doing that. Okay? I'm going to try and do this a little quicker. Okay? 10 years, 450, something like that. 12 years, 640. 14 years, 770. 16 years. 18 years. 20 years. Now that's kind of close to a straight line. It's not perfect because this data is what it is. When you get data in lab class, there might be a little bit of error. If you're doing timing, there might be some error with timing. You might get nervous. Who knows? That's okay. These points show us a pretty good relationship. In this case, hopefully you can see that as the number of years of education increases, your pay increases. That type of relationship has a special name. It's actually got a couple of names. In math class, maybe you've heard the terms positive correlation. In science class, we call this a direct relationship. When the x variable goes up, increases, the y variable increases with it. That's a direct or a positive relationship. There's other kinds of relationships. But before we talk about them, what you would do to sort of smooth out these rough edges is draw a best fit line. Here comes a best fit line. Something like that looks pretty good. I'm not freaking out because it doesn't go through every point, because I kind of realize there's a little bit of variation in the data. In lab class, there might be a little bit of error in the data, and the best fit line kind of smooths out those edges. It gets as close to all those points as it can while being a straight line. There might be times where there's curved lines. Probably not for direct relationships in our class, but that's something that as you get more experienced, you'll figure out. This is one kind of relationship, a direct relationship. There are times when the data doesn't behave like this. There might be times where as the x data, as the x values increase, the y values decrease. You might get something like this. Okay? If our first graph was a positive or a direct relationship, this would be a negative or an indirect relationship. Typically, in our class, it doesn't go straight down because then it might hit 0 for a y value. And a lot of times in science, that's not what happens. Sometimes, yes, but a lot of times you'll have data that looks more like this. It's getting closer and closer to 0, but not hitting it. That makes 0 an asymptote if you're thinking about math class. That's important. Don't ever do this. I'm going to do it in red. When we finish our graph for an indirect relationship, that's a lot of the times the way it looks. Some people, for some weird reason, go, hey, is that okay? No, it's not, because that's not what the data is showing. The data is showing that as you get closer and closer to low values for x, the y values are really big. That's an indirect relationship. One other type of relationship you might see would be that there's no relationship at all. The number on the y values has no connection with the x values. That's supposed to be a flat line. And then the last one, and we're not looking at the data on this graph in case you're getting confused. We're just looking at how data might show up. If you remember from Earth Science class, we did a lot with astronomy and Earth motions, sunrise and sunset, going around the sun and how it affects temperatures. Something like this. That's called a cyclic relationship. Those are the four big types of relationships we see in high school. There's probably others, but let's not go too crazy. What they all have in common is once you have data on a graph, it's not just a pretty picture. You can make predictions. Look at this graph. We started with 6 points, but because they're all related, we could connect them with a line. Now we have an infinite number of points on this graph. That means we can figure out other information. For example, we didn't plot 15 years of education on here, but let's say you wanted to know about how much money could I expect to make if I had 15 years of education. Well, you come right over to the 15, you go straight up till you hit the graph, and then you look across and you can interpolate how much you could expect. That works for all graphs. You could take your best fit line and use it to find more than just the 5, 6, 10 points of data you plotted. You have a lot more information on there because you know the relationship. That's a big deal with graphs. There's something else we can do with these graphs. We can find out a whole new different type of information. This line is not flat. It has a slope. Slope is a very important part of data collection or data analysis. A lot of times in this class, when I give you data to plot into a graph, the very next thing I'm going to make you do is calculate slope. So let's remember how we figure out slope. Sometimes it's written the change in the y values divided by the change in the x values. How do you do that? Well, you take 2 points and you take the second y value minus the first y value. Divide that by the second x value minus the first x value. Couple of important things about that. You're not going to use the dots that are just floating around on your graph. Remember, you drew a best fit line to smooth out the rough edges. So you're going to need to use points on that best fit line. Maybe some of your points are actually on that line. If they are, great, you can use them. But if they're not on that line, don't use them because they're going to give you some weird slope that's got too much error in it. I'm not going to spend too much time, especially with this graph, doing the calculations. But you would find a point maybe here and a point maybe here. And you'd have to work to figure out the x and the y values. And you'd take the y2 value minus the y1 value. Then you divide that by the x2 value minus the x1 value. And that would give you the slope of this line. And that's going to tell you something new, because if you do the y values divided by the x values, in this case, the units in this case are going to be the dollars you might earn for every year of education. Because you've got dollars on the y-axis, years of education on the x-axis. For some other graphs, we might be plotting time and distance, how far something gets in a certain amount of time. When you find the slope of that line, that's distance divided by time. Well, that's a velocity. That's what's so amazing. This is my conclusion for this lesson. This is what's so amazing about graphs. You plotted distance and time, yet you were able to calculate the speed of an object. Something that you didn't measure initially can be figured out by making a good graph and analyzing the data. So that's what it's all about. And hopefully you'll remember these things, or if you forget, you'll know that you can come back here and remember some of this stuff.